Hi everyone. Today we're going to start our journey into geometry, which is chapter 8. We're going to look at undefined terms such as point, line, plane, and angle that we use to define other terms in geometry, like ray and line segment. So those can't be defined unless we talk about point, line, and plane. So a point is just a location in space, and the way we symbolize a point is just with a little dot and then a capital letter. That's what a point would look like. So we will call that point P. And really there is no symbol for point. You would just use a capital P. We need 2 points to make a line. So through any 2 points, you can draw a straight line. And lines go on forever in all directions, so we have arrows on them. And I'll call this line XY. If I want to abbreviate it, I can start from either of the points. So I could call it line XY. I could even call it line YX. You can also see lines that are written with one letter. So sometimes they'll call it line L. When we take a line and we look at part of a line from one endpoint and then it continues on forever in the opposite direction, that's known as a ray. So think even of the sun's rays. I'll call this R and A. So we have to be careful how we name a ray. With a line, you can call it, line RA or line AR, but with a ray, you have to have your initial point, which is where it's starting, and then it goes on forever in the opposite direction. So here, this would be called line RA. Okay, it would not be line AR. That's not a good way to name it. Okay, line AR would look like this. I'm sorry, ray AR. It would have to start at A, and then it would keep going towards R. A line segment is part of a line that consists of 2 endpoints and all the points in between them. So when we take a line and we look at just from one point to the other, that's a line segment. So a line segment has a beginning and an end. So I might call that line segment AB. Segment is just a piece of or a part of something. So it's just a part of a line. So this would be known as line segment AB, and you can also call it line segment BA. It's the ray that you need to be really careful with how you name it. Again, you need to start with the initial point, which in the example I gave you was R, and then it goes in the direction of A. So that can only be read as ray RA. Here's a table of different diagrams and symbols. One of the things you might notice is that some of them have open and closed circles. So if we look at this right here, the book refers to that as a half line. It's not a ray because there's an open circle at A. So we refer to that as a half line AB. In part C, you can see the ray has 2 closed circles, and that's known as ray AB. If you look at line D, that would be ray BA. Notice that the initial point now is B, as opposed to in the line C, the initial point was A. And then you've got a line segment, and then F and G. In F, you've got 2 open circles, so that's called an open line segment. And then in G, you have half open line segments, very similar to the half line AB. It's got 1 closed and 1 open circle. And notice that in the symbols, they do the same thing. So if you're talking about half line segment AB, A is the closed circle and B is the open circle. So when you draw the symbol, you would want to make sure you put an open circle at B. Some of what we learned in chapter 2 and also talked about in chapter 3, we're going to use when we're looking at geometry. So if we recall, you've got the U symbol, which is union, and that's just the set of all elements that belong to either of the sets or both. And then don't forget that the upside down U is an and that it represents intersection of sets. And that's the set of elements common to both sets, so it's where they intersect at. So in this example here, we have two rays. The top one is ray AB, the bottom is ray BA. And in problem number 1, I'm looking for the intersection. So it's asking me, where does ray AB intersect with ray BA? So we're going to look and see what they have in common. So basically, it's just where they overlap. So anything in here is what's in common to both. And if you'll recall, it's got a beginning and an end. So that would be line segment AB is the intersection of the two rays. You can also call it line segment BA. Now when I'm dealing with number 2, this is union. So this is what belongs to either of the sets or to both. So now I'm taking both lines and basically picture it as you're placing them on top. So I'm going to take my top ray, AB, and I'm going to place it now on top of the bottom ray. And notice that it makes one complete line now. And the line that it creates is line BA. Or again, you can call it line AB. Pause the video and try numbers 1 to 4 on your own, and then you can unpause it and check your answers. So here we're looking at line AD, and we're answering the 4 questions. The first one says, ray AB intersects ray DC. Okay, so ray AB would have a beginning at A and keep going on towards B. So remember, it's going to go on forever though. And ray DC means it begins at D and goes on towards C forever. We're looking at where they intersect, which would be these two areas there, which is line segment AD. In number 2, ray AB in union with ray DC. So now I need to look at the elements that belong to either of the sets or both sets. So if I look at ray AB again, that's going to begin at A and go towards B forever. And then you've got ray DC, so what we had before, except now we want what's in common to both. So if I was to take ray DC and draw it right on top, you would see that it includes the entire line. So their union is line AD, or you could call it line DA. In the third example, you've got line segment AB. So that's the points between A and B. And then you have CD. And it's asking, where do they intersect at? They don't. So the answer is empty set. And in number 4, you've got line segment AD. And then remember, you've got an open circle there, so we refer to that as half line CA. So we're looking at their union. So line segment AD would go from point A to point D. And then I've got half line CA. So that's an open circle at C, and then it's in the direction of A forever. So again, we're looking at union. So if I was to put both of those geometric figures together, it would be everything from here all the way in the direction of A. So that would be ray DA. You might say, well, there's an open circle right there, but it's kind of, think of it as being filled in by this one right here. The next topic we're going to talk about is planes. A plane is just a flat, two-dimensional surface that extends forever in all directions. We're familiar with planes as kind of looking like this in textbooks. They're flat surfaces. They're usually named by a capital letter, so you could call this plane Q, for instance. But a plane doesn't have to have four sides. A plane just has to be a flat surface. So the smallest plane that you can make could be a triangle. That's a plane. So if I label this ABC, we would just call this plane ABC. Within planes, you've got lines that intersect, which means they cross, and lines that don't. So when we've got two lines that are in the same plane that don't intersect, they're referred to as parallel lines. So it's important to remember that parallel lines are in the same plane, and they're never going to intersect each other. So if I call this line XY and line WZ, we would say line XY is parallel to, so the symbol for parallel looks like a kind of a sideways 11, is parallel to line WZ. So they're in the same plane, which we call coplanar, and they're never going to intersect. Parallel planes are the same thing. So they're planes this time that are never going to intersect. And we'll see an example of that below. Skew lines are very similar to parallel lines. The difference is that they're not in the same plane. So the easiest way to think of that is in real life, if you've ever driven a car underneath an overpass, the road that's underneath the overpass and the actual highway above it, they're never going to intersect each other. But they're not parallel because they're in different planes. They're actually skew lines. So if you've ever driven underneath I-4 or even walked underneath I-4, the road that's going underneath I-4 and I-4 itself, they're skew lines. They're in two different planes, but they're never going to intersect each other. So if you can draw a cube even. So the way I do that is first draw two squares and then connect it. If I want to look at two skew lines, I could pick out maybe this line up here and then a line right here. Okay, they're never going to intersect each other, but they're in two different planes. So we refer to them as skew lines. Okay, so now we have a figure, and they tell us that the lines may be described by naming 2 points, and the planes may be described by naming 3 points. Remember, you can make a plane with a triangle. Okay, so again, we're trying to look at intersections and unions. So given this diagram, they want us to find what's the intersection of plane ABC and plane BCF. Okay, so let's highlight. We've got plane ABC, which is this plane here. And plane BCF. Okay, so where's BCF? BCF is this bottom plane. Okay, because you can see, connect the dots from B to C to F. Okay, it's this giant plane, including E, because you only need 3 points to make a plane. Okay, this is saying where do they intersect at? So look at the two pictures. Where do they intersect? And they intersect right here at line BC. You might say, well, I thought that was a line segment. Well, remember, planes go on forever in all directions. So lines go on forever in all directions. So it's actually intersecting in a line, not a line segment. In number 2, it says, what is the intersection of plane ABC and line DF? Okay, so let's take a look. So we've got plane ABC, which we saw earlier, is just this triangle right here, and line DF. So line DF is this line right here. Do they intersect at all? No. So the answer is no solution or empty set. Okay, now they want us to name 2 skew lines. So remember, skew lines are lines that never intersect, but they're also not in the same plane. So you have to pick 2 lines that are not in the same plane. There's a couple ways you could answer this. So I could pick perhaps, I could do line BC. So this line right here, okay, and then line DF. Those 2 lines are in 2 different planes and they're never going to intersect. So line BC and line DF. You could have also chosen line CF and line DE. They're also never going to intersect and they're not in the same plane. Okay, try and pause the video and try these 3 problems using the same diagram. So you're looking at the intersection of plane ABC and line CF. Okay, so again, here's plane ABC, here's line CF. Where are they intersecting? The only place they're intersecting is at point C. You may see your answer written in set notation, since intersect does pertain to sets. Now we're looking at 2 parallel lines. So these are lines that are in the same plane and don't intersect. Okay, so I'm going to pick a plane, like this bottom plane, which again, you can name it using 3 letters. So we could call that plane BCF. What would be 2 lines that look like they never intersect? One of them could be line CF, and then the other would be the line kind of behind it, line BE. So we would say line BE is parallel to line CF. Another example could be line AC and line DF. And now we're looking for 2 parallel planes. So we need to pick 2 planes that aren't going to intersect. And in this diagram, there's really only one answer. There's this plane in the front, and then this plane in the back. I think you'll agree they're never going to intersect. So we would say plane ABC is parallel to plane DEF. Next, we're going to talk about angles. So an angle is the union of 2 rays with a common endpoint. We call that common endpoint the vertex. So there's a few ways to name this angle. You can call it angle ABC. By the way, that's the symbol for angle. You could call it angle CBA. You could even just call it angle B. But what you can't do is call it angle BCA. Okay, that's a no-no. And the reason is because the vertex, the common endpoint, has to be in the middle. We measure angles in degrees, and you may see a symbol for measure, and it's an M. So this right here is read measure of angle, and then you would name the angle. So we're given a diagram here, and again, we're looking at unions and intersections. The first one is asking you for the union, and the second two are asking for intersection. So pause the video and try answering these questions based on the diagram, and then unpause when you're ready to check your answers. So in this first example, it's asking us, what's the union of ray BE and ray BC? Okay, so ray BE is this ray here. So it's got a beginning, no end. And ray BC would begin at B and go towards C. So what's their union? It would be both of those rays together, which would give us angle CBE. So again, it's the definition of an angle. It's the union of two rays with a common endpoint. The common endpoint is B here, which we call the vertex. So the answer is angle CBE. Or you could call it angle EBC. Or you could just call it angle B. In number 2, they want line AC intersects angle CBG. So line AC is this line here, and angle CBG. So CBG. Where do they intersect at? They intersect, so actually it might help you if I do it in two different colors. So let me change colors here. So first we've got line AC, so that's this line right here. Okay, and then I'll change the color. Now you've got line, or angle CBG, right? So here's CBG, so that angle. Look very closely, where do they intersect at? So they intersected right here at ray BC. The last question says angle CBE. Okay, so here we go again. So let me highlight CBE for you. There's that angle. And where does it intersect with angle CBG? Okay, so now we've got CBG. So let's do this one. So CBG. Again, if you notice, where they intersect at is right there. So that would be ray BC. Some angles that you may be familiar with that you've seen before, if we classify angles, there's 4 ways. You have a right angle, which always measures 90 degrees, and you'll have this symbol. It looks like a box or a square. That signifies 90. An acute angle is always less than 90 degrees. An obtuse angle is between 90 and 180. So it's got to be bigger than 90 but less than 180. And we call any angle that measures 180 degrees as a straight angle. And as you can see, this is also a straight line. So that's very helpful to know that all straight lines measure 180 degrees. So next we're going to talk about adjacent angles, and the word adjacent means next to. So they're basically two angles that are next to each other, and I did not spell that right. They are two angles that are next to each other. They have a common vertex and a common side, but no common interior points. So what that means is, if I was to draw, let's say, an angle that looks like this, and then I had another one inside there. So I'll call this angle A, B, C, and then I'll put a D here. So if I was to name the two adjacent angles, I would say angle ABD, which is this angle right here, ABD, just follow the letters. And then the other angle that's adjacent to it would be angle CBD. So if I was to highlight that now, CBD would be this angle. And as you can see, they have that middle ray in common. So that's the common side. But notice that they don't have any common interior points. I could draw points inside this angle and they're not inside the orange angle. Next, we've got complementary angles, and they're two angles whose sum is 90. Can show you a way to remember complementary. So if you write out like COMP, I'm going to magically change this C into a 9, and the O is already a 0. So just remember that complementary angles are 90 degrees. So in our example, we have a diagram and it tells us the angles are complementary. So we want to remember that means that they add up to 90. They want us to determine the measures of angles 1 and 2. So angle 1 is 8x minus 9. And angle 2 is just x. So we know that both of those angles, since they're complementary, they're going to add up to 90. So I'm going to put a plus in my equation and make it equal 90. So you know that anytime they tell you angles are complementary, automatically just make it equal 90 degrees. And now I'm going to solve this. So to solve this, I have to collect like terms. So what are my like terms? They're anything that has the same variable, same exponent. So I've got an 8x and an x. If I add them, I'm going to get a 9x. And then I'm just going to bring that negative 9 next to it, and then carry down the equals 90. Now the goal is to get x by itself. So I'm going to do the inverse. I'm going to add 9 to both sides. I'm going to move it away from the x. So now I have 9x, because negative 9 plus 9 is 0, so that goes away, equals 99. I'm going to now get rid of that 9 by dividing it, because it's the opposite of multiplying, 9 times x. So I'm going to divide by 9, and 99 divided by 9 is 11. So it asks me what are the measures of angles 1 and 2. So I have to go back to angle 1, and I'm going to plug in 11 for x. So 8 times 11 is 88 minus 9 gives me 79 degrees. So I know that angle 1 is 79 degrees. And luckily, angle 2 is just x. So angle 2 is 11. To check your answer, remember they're complementary. They should add up to 90. So 79 degrees plus 11 degrees does add up to 90 degrees. So that means we're good. In number 2, it says if angle 1 and angle 2 are complementary angles, and if the measure of angle 2 is 5 times the measure of angle 1, determine the measures of angles 1 and 2. Feel free to pause the video and reread that question a couple times if you need to, and then unpause when you're ready to solve it with me. So in this problem, they tell me right away, they talk about complementary angles. So I know that my equation is going to be equal to 90. But they don't exactly tell you what angle 1 and 2 are. All they tell us is the measure of angle 2 is 5 times the measure of angle 1. So I have the measure of angle 1 and the measure of angle 2. The only clue they give us is that angle 2 is 5 times the measure of angle 1. Well, I don't know angle 1. So when we don't know something, that's our variable. So I'm going to call that x. So now, for angle 2, I know that it's 5 times the measure of angle 1. So that would just be 5x. Remember that these are complementary, so they're going to add up to 90. So when I write my equation, I just have x plus 5x equals 90. And now you're going to solve for x. So since both of the x's are on the same side of the equation, I'm going to combine like terms. X plus 5x is 6x. Now I'm going to divide by 6, and 90 divided by 6 is 15. So remember, I need to determine the measure of the angle, so I have to take 15 and plug it back in. So I know that angle 1 is x, and x is just 15. So angle 1 is 15 degrees. Angle 2 is 5 times x. Remember, x is 15. So 5 times 15 is 75. To check it, if I add 75 plus 15, I get 90 degrees, which is what I want because they're supposed to be complementary. Next, we have supplementary angles. So the difference is supplementary angles, they add up to 180 degrees. Here's another way you can remember it. If you write out sup, you can change the S to an 8, turn that to a 0, and put a 1. So it's 180 degrees. In this example, they tell us angle 1 and angle 2 are supplementary. So now I know they're going to equal 180. We need to determine the measures of angles 1 and 2. Okay, so angle 1 is 3x minus 4, and angle 2 is x. So all I need to do is add them and make them equal to 180. So this is just like the, not the last example, but the one right before it, number 1. We're going to combine our like terms because I have a 3x and an x on the same side. So if you combine them, you get 4x. And then I'm just going to bring the negative 4 down, and I'm going to bring the 180 down. And the goal is to get the x by itself. So I'm going to add 4 to both sides. Remember, you're always doing inverse operations. So we get 4x equals 184. And then my last step is to divide by 4 because it's the inverse of multiplying. And when you divide 184 by 4, you get 46. So I'm not finished because it didn't ask me what x was. It asked me what's the measures of angles 1 and 2. So now I have to plug them in. So angle 2 is just x, so that's easy. That's 46 degrees. For angle 1, there's a couple ways I could get my answer. I could subtract 180 minus 46, or I can just plug in 3 times 46 minus 4, and you end up getting 134 degrees. Our next concept are vertical angles. So vertical angles are angles that have the same measure. They kind of look like scissors if you were to open them up. So if I was to call this angle 1, 2, 3, and 4, the angles that are across from each other, like 1 and 3, they're vertical and they're always going to be equal. So angle 1 is going to equal angle 3. And the same goes for angle 2 and angle 4. And these concepts we've been talking about, vertical angles, supplementary angles, complementary angles, they're all going to help us solve problems dealing with angles. So it's important to know their properties. Now we're going to talk about angles formed by two intersecting lines and a third line. So that third line is the transversal. It's a line that intersects two other lines. In the diagram, the transversal is the red line. And what happens is it forms different angles. And there's 3 types that we're going to look at. One of them are called alternate interior angles. So the word alternate means to jump back and forth, and interior means inside. So when we're looking at the inside angles, we're looking at 3, 4, 5, and 6. To alternate again means to jump. So that means angle 3 and 6, if I jump over the transversal from 3, now I'm at 6. So 3 and 6, they're alternate interior. The same go with angle 4 and 5. If we're looking at alternate exterior, now we're looking at the outside angles, 1 and 2, 7 and 8. So again, we're going to alternate, we're going to jump over. So angle 1 and angle 8 are alternate exterior, and angle 2 and angle 7 are alternate exterior. And then last we have corresponding angles. So to correspond with something means to match up with it. So think of this as 2 tables, and you're sitting at seat number 1, and now you want to move tables. If you go to the other table, in order to be in the same seat, you would have to be in seat 5. And your friend that's in seat 2 is now going to be in seat 6. And the person at seat 4 would be at seat 8, and the person at seat 3 would be at seat 7. So the angles that match up are the corresponding angles. Something that's special about these angles is If the two green lines are parallel to each other and the transversal intersects them, those angle pairs will all be congruent to each other. So I'm going to make a little note here that's really important. If the lines are parallel, the angle pairs will be equal to each other. So what I mean is, if this, in the first example here, if those lines are parallel, the two green lines, and the transversal goes through it, then angle 3 will be equal to whatever angle 6 is, and angle 4 will be equal to whatever angle 5 is. So let's take a look at an example. In this example, we've got two lines, and it tells us they're parallel. So this is line 1, and this one's line 2. And they're parallel, okay? And it tells us, don't ever assume lines are parallel unless it's stated. So they're cut by that red line, which again, remember we call that the transversal. If the measure of angle 8 is 52 degrees, determine the measure of angle 1 through 7. So you might think, okay, they only gave me one angle. How do I find all the other 7? We're going to use those angle pair relationships that we just learned about. So one of the angle relationships that I like, because it's easy, is vertical angles. And if you'll recall, vertical angles are always equal. So what would be vertical to angle 8? It's angle 6. So angle 6 is also going to be 52 degrees. Okay, now, in order to get the angles up top, I'm going to use what I just learned, my alternate interior and my corresponding angles. So now, if you'll remember, as long as you have parallel lines, alternate interiors are equal. So that means angle 4 is also 52. And then again, I can use vertical angles. Angle 2 is equal to 52 because it's vertical to 4. Now, how do I find my other angles? Well, remember that if you have a straight line, there's 180 degrees. So if I'm looking up top at angle 1 and angle 2, they have to add up to 180 because they're sitting on a straight line. So to figure out angle 1, I'm just going to take 180 and I'm going to subtract 52. And that's going to give me 128 degrees. Now angle 1 and 3 are vertical, so they're equal. And now angle 3 and 7, they're corresponding. They're in the same spot, just a different line. So angle 3 and 7 are 128. And angle 7 and 5 are vertical. So they're 128. Okay, that takes us to the end of section 8.1. And if you have any questions, please let me know. I know geometry, it's been a while since some of you have taken it, and it's not always the easiest because there's a lot of things you have to recognize and remember. But with practice on my lab and looking at these examples and practicing them, you should be okay. But I am here to help you. If you need help, please reach out to me. All right, enjoy the rest of your day or night, everyone.